Hi, so welcome to this first video for Introduction to Data Science. So hopefully you've met us all in the Meet the Team video. My name is Alex Homer. You can call me Alex. And let's get started. So let's start with a quick hello world. And I'm using that phrase because that's a fairly common phrase. You've probably come across it before as a first computer program. That people learn how to write. They learn how to write a program that says hello world. So I'm going to say hello world to you. So as I said in the last video, I'm a university teacher here in the School of Maths, and I'll be doing some of the videos for this course, and so will David. You'll see him as well. And I just want to say at this point, these videos, as you've probably already worked out, they're not going to be sort of polished, scripted videos in the way you might be used to seeing on YouTube, even though you can watch them on YouTube. These are going to be a bit like real life lectures, but of course delivered in a recorded format. So that you might find the odd mistake, you might find the odd stumble over words, and I hope you forgive that. So you'll see me and David this week, and you'll see us again from time to time later on in the course, but after this week, it's going to be mostly someone called Dr. Mina Chitinkaya-Rundell, who hopefully you also met on the Meet the Team video. So Mina recorded these lectures last year, and we're using her lectures again. They were very good. There's just a few at the beginning where we need to change them, just to reflect the fact that this year is slightly different from last year. It's a little bit more in person, and also just the staff have changed. I'm here. And I was not here last year. So we're very excited to teach the course, and I think it's time to get on with it. So this is a data science course. What is data science? So it's a discipline that lets you turn raw data into understanding, insight, and knowledge. It's quite exciting. It's quite a growing discipline. There's a lot of jobs in data science these days. And in particular, we're going to learn how to do our data science in a tidy way. And I realise I haven't said what tidy is, but you'll notice it's in that sort of monospace font. It looks a bit different. It has a specific meaning, just tidy in this context, but we'll cover that later. So you'll notice there's just been a cut there. I told you this wasn't going to be polished. But this is a course on Introduction to Data Science with an emphasis on statistical thinking. So let's move on to some questions that you might have about the course. So the first question we get, and we get a lot, is what data science background does this course do? And the answer is absolutely none. If you've never done data science before, you're very welcome here. And if you've done lots of data science before, you're also very welcome here. So your next question might be, is this an introductory stats course? Because data is a thing that stats deals with. And the answer is no. This is a data science course, and data science isn't quite the same as statistics. And you'll find statistics courses as you go through your degrees here. But it is worth noting that data science and statistics are very closely related. They have an awful lot of overlap with each other. So this is a really good way in your first term at Edinburgh to get started with statistics. However, it's not your typical sort of high school A-level hires statistics course. I did some statistics at A-level and hated it, and it was only when I got to uni that I really liked statistics. So hopefully, even if you hated statistics before, you like something out of this course. And one thing that's very different from the way a lot of statistics is taught for exams is that this course involves a lot of computing. So one question we get is, will we be doing computing? The answer is very much yes. We'll be spending a lot of time coding, and most of the work you hand in, or much of it, will be writing computer code and submitting that. So then, if this is a coding related course, is it an introductory computer science course? Well, no. It's very much a data science course, but a lot of the themes are shared. We'll be looking at how to control programming flow and so on. There's an awful lot of languages, so which one are we going to learn? We're going to learn the programming language called R, just the letter R. It's a very data-focused course. It's also one that's used quite a lot in academia for data. There are other languages. Python's used a lot in industry for data science as well. So you might want to ask, why are we not covering that? And that's a question that could lead to quite a long discussion that we're not going to have here. But if you'd like to come to our office hours and have a conversation about that, you're very welcome to. Okay, so the most important slide in this presentation is the next one, which is this link, IDS Ed, that's Intro to Data Science Edinburgh, .digital. It's one of the new domain names that you can have that isn't .com or .uk or anything like that. So idsed.digital, if you type that into your browser, you will get the course website, and almost everything that you need in this course is on that website, or at least links to the things are on that website, so like videos you can watch on YouTube. The only thing that you will not find on the website is your course marks. They have to be done through a university system, but there'll be some information about how to access those on the website. Right. Let's talk about software a little bit. So I mentioned that we'll be using a language called R, but if you've heard of data analysis before or done any data analysis before, you're probably thinking of something like this. This is Microsoft Excel, and it's showing some of the data we're going to use. And yeah, this is what data analysis meant to me before I went to uni. It's still what data science, data analysis means to an awful lot of people, and maybe to you. Excel is still very widely used, but it has some limitations. A really key one being that the data and sort of the analysis of the data aren't kept separate when you're using Excel. They all have to be in the same place. And sometimes that doesn't work well with a workflow. And so what we're going to be using, as I say, is R. And when I first used R, it looked something like this. This is what it looks like on a Mac. It looks very slightly different on Windows. And that might look a little bit intimidating to you. So well, this is a program for your data, right? And where's the data? There's just some code, there's some plain text there, and then a line prompting you to type something in. There's also very few buttons to click. So if we go back to Excel, you've got all the buttons along the top, you've got a nice tab that says data on it, and we've got nothing like that here. We've just got buttons on the top, and if you look at those, they're more to do with programming things rather than to do with actually analyzing data. So this might be a bit intimidating. Don't worry if it is. We're going to talk you through it. We're going to get used to using something like this. We're not actually going to use it looking like exactly this, though. This is what R looks like when you first download it to your computer, but we're going to use something called RStudio. I should say you don't actually have to download R to your computer for this course. You're very welcome to, but everything we'll be using is in a form of RStudio called RStudio Cloud. So like most cloud things like Google Sheets or Google Docs or anything like that, we will be using a cloud editor, so everything's going to take place on the internet. So hopefully that makes it a little bit easier for you. But yes, we're using something called RStudio, and this is what's known as an integrated development environment, or IDE. Don't worry if you don't know what an IDE is, but that's just what this is. In simple terms, an IDE is a way that you can write your code, your computer code, and also see the results of it to an extent in a more user-friendly way. It's very common to use an IDE. RStudio isn't the only one that exists, even for R, but it is the one we're going to be using in this course. So in particular, you'll notice the bottom left, that text that's there looks very much like the text that you saw on the previous slide. And in fact, it's exactly the same text. This is a screenshot from 2020, so it has changed a little bit since then. But yeah, the bottom left is kind of a copy of what you saw on the previous one. And then we can also see the data at the top left. So this is already looking a little bit friendlier because we can see our data as well as being able to see our code. There's going to be lots of buttons when you first see this. You don't know what they mean. There's these different panes that do different things. Don't worry, we're going to go through what everything means in the course. But this is just to give you an idea of the kind of thing, what you're going to be seeing when you first log in. Right, so we've talked a little bit about the software. Let's just talk about how we do data science. And we're going to talk through this chart. So this is a chart from a book. It's called R for Data Science. The book is called R for Data Science, and that book is available for free online, completely legally. The authors have put it online, and that's going to be one of the key course textbooks. So I strongly recommend, in fact, the course requires that you read certain sections from this, but we're going to talk through this diagram right now. It shows different stages in a kind of data science journey, and it's worth saying before we go any further that this is not the only diagram that we can use to kind of visualize data science as a process, but it's a fairly common one. So it shows the first stage, which is importing. So before we can do anything, we have to somehow get our data into our software. We might have collected it ourselves, we might have downloaded it from the internet, from collaborators, from all sorts of places, from maybe some automated software in a business, like order software that will export the data of what orders have taken place. And we have to get it into, in our case, R. And it would be great if we could just get on with it right then. But real world data is usually messy. So we're going to have to do something more. We're going to have to clean it up a bit. So that's the stage that's represented by the word tidy there, a word you'll keep seeing in this course. So we're going to need to get our data into a nice tidy form, which will mean getting it into a nice rectangular form. So rows representing different observations and columns representing different variables. So for instance, rows might represent orders and columns might represent the product that was ordered and the customer number and the price and all those kind of things. We might also need to go further than just getting into the rectangular form. It may be that there are errors in the data that we need to fix. So we shouldn't just remove things because they're outliers, because they're a long way away, but it might be that something is very obviously an error or has been imported incorrectly. So it might be that something represents missing data, for instance, and we need to make sure that the computer understands that these are missing data. This isn't a data point that's called missing data. And then we might also want to transform the data, so maybe change some variables or things like that to get exactly the table of data that we need for the analysis we want to do. And then a fairly standard next step would be to visualize the data. So we want to try and get some initial insights from this and make some plots, show maybe some scatter plots, some bar plots, histograms, things you've probably heard of before. And those might start to give us an idea of what patterns are in the data. And once we've got a bit of an idea, we can try and formalize that a bit more by modeling it, by sort of creating a formal mathematical relationship between things or trying to see if one exists. And again, it would be great if that was it. We modeled it, great, we're done. But usually you want to do a bit more than that because usually the modeling and the visualizing will start to give you some insights that mean you need to do some transformation again and then visualize and model. So it's a cycle. And this is a cycle of understanding. That's what the word understand is doing there. So by going through this cycle, we start to understand our data more and more. So before we talk about the rest of the diagram, let's have a look at what that cycle might look like for a real world example. So here is a numerical summary of searches on Google, which is called the Google Trend Index. And in particular, we're looking at the travel index. So this is looking at queries for things like flights and beaches and all sorts of things that are associated with holidays, and it's all data from the US. So the US is in the Northern Hemisphere. Its summer is in the months around June, July, August, September maybe. And so we might expect, our intuition might be that more searches would appear during the summer for things to do with holidays. And if we look at the visualization of the data, that's exactly what happens. We get this sort of annual peak pattern with the peak always coming in the summer. But that's our sort of visualization. The raw data we got it from actually might be something like this. So it might have a set of dates and a number of searches. This is just an example. That's not the actual data set. And our transformation then, we might want to apply a transformation to this. And our transformation might be, okay, well, which season are these in? We've got this idea from the visualization that we get peaks in the summer. So maybe we want to transform it and say, okay, let's take each date, turn it to a season, and then we'll do some analysis on how things differ between the seasons. So we've done the visualization, we've skipped the model stage for now, but then we're going to do a transformation. And so we'll go through a cycle a few times. It might be that after going through it a few times, we're happy with what we've got, or it might be that we reach a deadline and we have to say something. So at that point, we want to communicate our results. But if you're anything like me, you might be a bit uncomfortable with that, the fact that suddenly we get to the end and oops, we've got to communicate it now. So it feels a bit like leaving your coursework to the last minute, which is something we really don't want to encourage you to do. So we're going to be adding communicate into the cycle. So the way we're going to do that is use an environment that will let us do our communication and our analysis at the same time alongside each other. So this is going to be something called R Markdown. R Markdown is a kind of extension to the R programming language that lets us both write our code and write our analysis in the same window, essentially, and neatly produce a report from that. And that all comes within RStudio. And one final aspect of this diagram is the word program, which is outside the diagram. So it's not outside because it's less important in any way. It's just that programming is involved in every single one of those steps. And as we said, even in the communication step, when we're doing this report, there are aspects of programming involved in writing a report using R Markdown. So all the way through this process, we're going to be teaching you how to program with R. Okay, so this is an example of the kind of workspace, the kind of environment that we're going to be working in throughout this course. This is the RStudio IDE. And I've removed certain things from the view. Normally you'd see 4 panes in here, but we only have 2 here. We have the 2 most important ones, perhaps, for what we're going to be doing. We have one on the left, which is code or monospaced font. And we've got one on the right, which is a report that you can easily read. Maybe it looks like a PDF or a web page or slides, say. We'll see a few different kinds of things that are going to go on the right there. And these maybe don't look like they're particularly related to each other as the animation sort of scrolls through them, but actually there's a really strong link between them. The code on the left generates the document on the right. And if you have sort of one goal in mind for this first week of IDS, it would be to get a bit of an idea of the link between the 2 sides of this view. All right then, let's get started and have a look at our first example of a data science project. And this is going to be some data from the United Nations General Assembly. So that's where most things that you might consider countries in the world turn up at this venue, as you can see on the screen. This is the General Assembly Hall at the UN headquarters in New York City. And at that, there'll be different propositions on different issues, and countries will vote in yes or no on those issues, on those votes. And we're going to look at some data that tabulates how the countries voted on each of those issues. This is from a package called UN Votes. You can see the citation information in the application exercise. So we're going to look at 3 countries here, which are countries chosen by Mina as particularly important to her. And those are Turkey, the UK, and the United States. And we're going to look at 6 issues here. So we've calculated for each year in our sample the percentage of votes in that year that were yes or no for the issues of arms control and disarmament, colonialism, economic development, human rights, nuclear weapons and nuclear material, and the Palestinian conflict. So let's look a little bit more deeply at what's going on in these plots. So on the y-axis, we have the percentage of votes that were yes for each year. We don't know what yes means. Yes might have meant something slightly different in each vote. But as a rough guide, we can have a look at what percentage of votes were yes, because at least that might be able to show us some trends and sort of differences of behavior, even if we don't know exactly what a yes vote would mean. On the x-axis, of course, that means that we're going to have the years. So we've got a data point for each year, which is the percentage of votes that were yes. And then we've got these 6 panes. Each of these panes, or facets, we're going to call them facets in this course, represents one of the 6 issues. So we've got a different little graph for each issue. And that's because we've got the countries represented by colors, for instance, so we can't have a color for each issue or a different line on one graph. It will get very confusing. So one way of doing that is to have a separate little plot, a facet for each of the issues. So one thing that we can see when we look at this, as I say, differences in behavior are something we're going to be able to see from this, given that we don't know exactly what percentage yes means. And also where we see these kind of divergences in behavior is often where something interesting is going on. So you'll notice there's a broadly similar trend for the 3 countries under arms control and disarmament, but let's have a look at the Palestinian conflict one. That's very much not true. There's a lot of difference here. Turkey tends to vote yes, it seems, in issues related, at least recently, on votes related to the Palestinian conflict, and the US tends to vote no. We're close to 100% and 0% on those 2 things. So if you know anything about the politics of that part of the world, you might know that the US and Turkey have very different policy positions on that issue. And so it makes sense that they'd be voting very differently. So this is a plot that matches our intuition. But what if it doesn't? What if we get a plot where actually, no, this isn't what we would have expected to happen? So that could mean one of 2 things. It could mean that we've done something wrong. And so whenever that happens, it's always worth going back and looking to see if there are any mistakes that you've made. But it could be that that's just that you found something surprising in your data. And of course, if our plots always matched what we thought we were going to find beforehand, if our results were always the same as what we thought beforehand, there wouldn't really be very much point in doing data science at all. So that's the time where you might want to say, update your beliefs, change your beliefs, um, to reflect this new information that you've gained from the data. So as I say, I'm not going to take you line by line through how we did this. If you want to look at the code in more detail, you can see it on the application exercise, which is the next video. But let's talk a little bit through how we did this. So the data actually comes from 3 tables, and in the application exercise, those will already be put together for you. But in a basic analysis, and I'm going to show you some code for this, you would first have to put them together, you'd then have to analyze them. So the 3 tables are called UN votes, UN roll calls, and UN roll call issues. So here's some code that produces this plot. So as I say, won't discuss it line by line, but firstly, you'll also put little boxes around 3 phrases, and those are UN votes, UN roll calls, and UN roll call issues. And those were the names of the data tables that we were looking at. So you can see that this maybe this is the first indication that this isn't just abstract nonsense. These really are things that relate to something you can maybe understand. And hopefully give you a little bit of confidence as we talk through this a bit more that you'll be able to write something like this. So the next thing I'm going to point out, we've got the phrase inner join here, inner underscore join. I said we were going to have to join these data tables together, so that's a function that does that. So again, we're starting to see things that reflect maybe our intuition of how we should go about analyzing these data. The next line after that actually says filter in it. So if you're filtering something, you're selecting certain things and removing others. So maybe this is a good indication we're not looking at every country. And yeah, it says then country in, there's a little C, we won't worry about what that means just yet, but then it says United Kingdom, United States, Turkey. We're selecting 3 countries. And another thing I'm going to point out is that there's the word, well, it's not a word, but ggplot appears. So let's not worry about what the GG means just yet. But the word plot is there, and a plot is a kind of graph. So maybe that's the code for plotting something. So we can see different things here. We're joining some data sets, we're filtering through, we're plotting something. These are all things that you might expect. And the words that we use in R to represent them really are words that are related to what they do. One last thing I'm going to point out that you can see as a straightforward correspondence between the code and the graph is that it says title equals percentage of yes votes in the UN General Assembly and subtitle equals 1946-2019. And that's exactly what the title and subtitle say on the plot. So again, that corresponds directly between the code and the plot. So I'm going to go back to the sort of wider environment that we use to code this. So this is the thing called R Markdown. So R Markdown is this process where this system where we can write R code and we can also write text that explains what our R code does. So this is very part of this process of writing up, of communicating as we code. And you'll notice there's text on one side here and on the right hand side, and there's code on the left hand side. So there's some text in the blue box there. Sorry, there's 2 different things in the code. There's some things with a grey outline, and there's an example of one in the red box, and there's some things that don't have any sort of shading at all. So grey shading, we've put a red box around here, and without the shading, we've put an example in a blue box. So you can actually see if you zoom in closely that the code, so the code that's in the red box appears on the right hand side in a little grey box, grey shaded box there. And the text goes from this sort of monospace font on one side, this typewriter font, it goes to just normal text that you can read like you would in any other report. So this is a way of getting from something that looks like code to something that's an actual, or just some code, to something that's a report that other people could read. And one of the things to point out here is that right up at the top there, there's some what we might call metadata. So there's a title and an author and a date field, and those correspond to a title, author, and date field on the other side. And the R Markdown environment that we're working with here has also created a nice little contents page for us, or contents menu at least. So this environment that you can see here is something we're going to be using all the way through this course, and maybe a goal for this week, as I say, is to get used to how we go from something we want to do to writing code to making a nice looking document. We're not going to learn vast amounts of code this week, we're just getting used to the kind of environment that we're going to work in. So to play around with the data, if you want to do that yourself, there are two things that you can do here. So one of them is that there is an application exercise, which I'll talk about in the next video, a little bit about what that involves. And I strongly recommend having a go at that. There's also an alternative option though for that with some coronavirus data. We'll talk about that in a minute, or in the next video rather. The other thing you might want to have a go at is going to that web address there, minacr.shinyapps.io/UN votes. That's a link to a sort of web app. It's called maybe something called Shiny, on which you can select different countries and show the graphs for those countries. So Mina put that together. You can go to that website and you can play around there if you like. So I hope that's whetted your appetite a little bit for what's going to be in this course, and I'll see you in the next video where we'll talk about the first application exercise.